Welcome to the night class. This is your friendly math teacher, Coach Knight. Today we're talking about different types of functions, 3 in particular, okay? We have, to date, studied linear and exponential and what? Quadratic. Okay? So, just a brief little refresher. What's the graphs of linear? Looks like looks like a line, right? Okay. What about exponential? Do y'all remember what those look like? It's like a ramp, kind of, huh? They kind of go, and they go up real fast.
But they never reach zero.
Yes, exactly. All right, and then your quadratic looks like a
Parabola.
A parabola. Okay. So everybody remembers that, right? What about your equation? What's the highest degree on linear equations?
I don't remember.
1. So it's like y equals x. Okay. Exponential means your variable is what?
Greater than 0.
Your variable is the what? Exponent. That's why it's called exponential. Okay, so it will look like y equals ab to the x power. Okay. Quadratics, what's your highest degree? 2. So it's going to be x squared. Okay. Brief little summary. We are going to combine and look at data and be able to tell which one's which just from the tables. Okay. So it's very, very simple. The first one says, how can you determine whether the data in the table can be modeled by a linear function? Here is how. First off, your x values, they have to be changing by the same amount. See how they're all going up by 1? Okay? That goes for all of these. That's your first thing. If these aren't changing the same, none of this other stuff works. You got me? You have to make sure they're going up by the same amount or going down by the same amount. Okay? If you find the first differences of your y's, now difference means you're doing what kind of math? You're subtracting. So I'm saying 1 minus negative 1. 1 minus negative 1. What do I get? 2. Here I'm saying 3 minus 1. I get 2. 5 minus 3. 2. 7 minus 5. 2. If they are all equal to the same number, it is linear. Okay? So this, if you graphed them, would make a line. Everybody good with linear? Okay? If they don't, okay, you find the second differences. Well, the second differences means I've already found the first differences. Notice, again, these are all going up by 1, right? Okay? I've found 9 minus 3 is 6. 19 minus 9 is 10. 33 minus 19 is 14. See how none of those first differences are the same? I do that again from the differences. What's 10 minus 6? 4. 14 minus 10 is 4. 18 minus 14 is 4. If the second differences are the same, it is a quadratic. Okay? Now, we're not doing the next one. If we did it again, what do you think it would be? If the first differences is a line, the second differences is a quadratic, the third differences would be a nope. She said a cubic. Okay? It'd be to the third power. If the fourth differences are the same, it's to the fourth power. Okay? So, second differences, quadratic. First differences, linear. Easy peasy so far? Okay. Exponential is a whole different ball game. Okay? So, exponential, they did it here. Again, x's are going up by the same amount. First differences were 1, 2, 4, and 8. Second differences were 1, 2, and 4. Here's how you do exponential. You don't do adding and subtracting at all. It's multiplying by something. Okay? So in other words, what's 1 times 2?
2.
What's 2 times 2?
4.
What's 4 times 2?
8.
What's 8 times 2?
16.
Okay? That you're finding the ratio of the values rather than the differences. Okay? To be honest, I would, if I'm looking the question saying which one is these, is it? I would start with this, okay? Because if you start with the first differences and that ain't it, well, then the next thing you're going to try is what? The second differences. And if that ain't it, well, now I'm going to have to go and do this. So if you start with this and it's right, you can quit. Does that make sense? Okay? Yes, ma'am.
Will there be times where you can automatically assume it's going to be exponential if you do it twice? Or no?
I wouldn't go that far because, like I said, there are other functions in the world. Just because we're not studying them doesn't mean they don't exist, and I don't want you to get in bad habits. Does that make sense? So the third ones could work, and you don't ever do them. And because, like I said, we don't do cubics in Algebra 1, so that would cause you to miss it later on when you get to Algebra 2 or whatever.
But like
okay?
this week on the
But
test.
for this week on the test, yes. Okay? But like I said, if you're multiplying to get the next y, you know it's what? Exponential. Okay? Now, they make it all sound cool and stuff. And the same vice versa. If it's linear, you're doing what to get the next y? Adding or subtracting. Okay? So that's all you're looking at. Okay, we call it differences and ratios, but all ratio is you're dividing to get what they multiplied by. So to get this, we said 2 divided by 1 was 2. Okay? 4 divided by 2 is 2. 8 divided by 4 is 2. All right? So those are what you're looking for. Everybody good? All right, let's try one. First thing I'm going to check is what? Again, it's just my way. Exponential. Am I multiplying by the same number to get these new numbers? No. 2 times what would give me 5? No, there's something.
Testing is probably.
It's 2.5. But is 2.5 times 5 14? No. Is that making sense? Okay. So I know it's not exponential. So let's see here. What's happening here?
Negative minus a negative, so you're adding
It's subtracting 3. What about that one?
9.
Subtracting 9. So is it linear? I know it's not linear, so it's probably going to be what? Quadratic, but I'm going to make sure, okay? That would be negative 15. And that's negative 21? 21, right? All right. So those didn't work. What about here? That's going down how much? 6, negative 6, negative 6. So it is quadratic because the second differences are all the same. Everybody good? Okay.
What do you mean by like the second difference?
These were the first differences. Differences just means I'm subtracting. I'm saying negative 5 minus negative 2 and getting negative 3. I'm saying negative 14 minus negative 5 and getting 9. Or you can literally think about how much are they going down each time. Okay, that's really what I'm doing. I'm saying how much did they subtract from negative 2 to get negative 5? They subtracted negative 3. Okay, or just say subtracted 3 actually. All right. Here, again, I'm going to start with what? Are they multiplying or dividing to get the next one? So what's 4 times what equals 12? 12 times 3 is?
36.
So I multiplied by 3 here, multiplying by 3 here. What's 36 times 3? 108. Multiplying by 3 every time, right? So that must be what? Okay? If I asked and I said, hey, what's the ratio? What would you say? 3. All the ratio is what are you multiplying by to get the next one? Okay? Every time. Easy peasy? Wonderful. Example 2 says choose a function type for real world data. All right, so we have this data over here, and it says the owner of a framing store tracks the cost of, is that bubble wrap? Bubble wrap. I love that stuff. You pop it and, you know, everybody does that, right? That's not just me, right? That's good. Good stress reliever, okay? How can you use the data to estimate the cost of the bubble wrap for a picture with a length of 75 inches? So, what we are going to do is, well, first I'm going to see which one it is. Is it linear? Is it quadratic? Is it exponential? Okay? So, it doesn't look like it's exponential because what's that? 1.1 that'd be times, that'd be what? That'd be 31? Is that right? 0.31 divided by 0.1? That's 31, right? My pen, it bleeds. How my digital pen bleeds, I don't know, but it does, okay? What is 0.62 divided by 0.31? That's 2, right? So, and I put 31 there. I should have put 3.1, right? Sorry about that. So, that's not the same. Our differences, though, let's see here. What's our differences here? How much did we go up by? 0.21. Then how much? 0.31. Y'all tell me. So 0.4 what? 0.42? And 0.53. Okay. What about my second differences? It's just 0.1, 0.11, 0.11.
So it's nothing?
Okay. So
I'm gonna look at the
It might, I don't know. No,
is it
it's not.
any of them exactly?
No.
It's none of them exactly. Okay? So I'm going to go back down here. I want to put, what did we get when we divide those? 3.1. And we had, what, 2? What's 1.04 divided by 0.62?
3.1, what?
I'm dividing 0.31 divided by 0.1. And I got 3.1. And then I did 0.62 divided by 0.31, and I got 2. So I'm asking what's 1.04 divided by 0.62? 1.68? All right. And then lastly, what's 1.57 divided by 1.04? Okay, so here's my ratios, here's my first differences, here's my second differences, okay? Ratios, first differences, second differences. None of them are exactly correct, right? So that means it's not an exact line, it's not an exact quadratic, it's not an exact exponential. Which one's the best to use, though? Why do you say the second? Because the book said so. Look at it without the book. Because they are all the closest to being the same. Does that make sense? Okay? 0.21, that's not too far apart. It's just the second differences are very close to each other. We're talking about 10, 11, and 11 if you took the decimals off. Okay? So I'm going to say it's quadratic. So what I'm going to do now is I'm going to go to my calculator and hit stat, okay? And you type these in, okay? Do I need to do it, or do y'all know what I'm doing?
I guess I'll do it.
Let me get out of here. I'm going to need y'all's help, though, because I don't know the numbers to type in. So stat, edit. What's my L1s?
6,
All right.
12, 18,
24 and 20
30.
and 30. All right. And then over here,
0.10,
0.1,
0.31,
0.31, 0.62, and I forgot after that.
1.04, 1.57.
All right, so I type them in my calculator. I go to stat again. I go over to calc. And here's what I want you to understand. If it had been linear, I would have used linreg. If it had been quadratic, which it is, I'm going to use quadrag. if it had been exponential, if you keep scrolling down, there is EXP reg. That's when the exponential one. Okay? So you can get your graph, or your equation, your function from the calculator. Okay? You just got to know what type of function it is.
Well, you can just keep.
Okay? So, well, you could, but that takes a little while. So I know it's a quadratic, or close enough to a quadratic, so I'm going to go down here to calculate. Remember the r squared yesterday?
It's close to
Remember how remember if it's close to what? 1. If it's close to 1, that means it's very close to being a quadratic. This is extremely close to being a quadratic.
Why don't they just make
Okay.
it 1? Why do they gotta do that?
Just to show you that it can be a little off. Okay?
It's not exact, but
It's not exact. So, y'all got this in your calculator? Because I'm going to need you to read it back to me in just a second. Y'all got it?
Yes.
Okay.
Hey, what did we do yesterday that makes it have the R2?
Go to mode and scroll down to stat diagnostic, and you want it on. Mode. There you go. Mode, scroll all the way down. And it says stat diagnostic. Mode. Scroll all the way down. Stat diagnostic. Yes, you want to cut it on. You want to make sure it's on. And then go back and do the same thing. Okay? All right. So, somebody read to me our equation we have. We have y equals round to the, let's say 3 decimal places, because I don't want to do 10,000. We'll just go thousands this time. So what was A? 0014. All right. X squared. Then what? What was B? Plus 0.0075x. And then what was C? 0.002. Okay? And they want to know what's the cost going to be at bubble wrap with a length of 75 inches. So what do I do with 75? Plug it in. So bubble wrap. That's the latest. That's the new craze.
Wait, so we have to find the equation too?
You have to find the equation so you know what to plug into 75 into.
It makes sense.
Miss Deborah Davis, if you would please come to the front office.
What does possibly? What does it say? What does it say? What do you get when you plug in 75?
Oh.
You should get about 9.01 according to the book, but I don't ever trust the book. So you put it in your calculator too to make sure that's what we get. I should see everybody reaching for their calculator and plugging it in.
I got 8.4.
43. See, that's. Huh? How bad did we round? Did we round a bunch?
They didn't. Probably. They probably didn't.
They didn't round it all. In the book, they didn't round it all.
No, I don't think
Okay.
they rounded.
No, they didn't. I see. Oh wait,
I don't think we rounded.
we didn't round. They got .0015. Y'all told me 14.
Not me. It wasn't me.
I didn't round that far. I'm sorry.
I
didn't think to round. The next one's 6 then too. I'm sorry. I'm really sorry.
I'm glad you did it because that's not far off, but it made our answer wrong. You see what I'm saying? And it's not that far off. What's the answer in the book? 8. Okay, so really it is kind of off because that's $8.43 and that's $9. So you just cost us what, 64 cents?
I'm sorry.
Hey,
I was wondering why you didn't round it, and I was like, yeah, he's writing it down, so I guess it's right.
When I'm asking y'all that, I don't know. So if you tell me wrong, I'm writing it down wrong. So, all right, no big deal.
I'm doing good.
You understand the process there, right? Okay, so this should have been what, 5? Is that what? And this should have been 6? What about that one? Is that one okay? Okay, all right. So if you plug that in, you should get 9.01. All right? Any questions on that? Awesome. Let's try some. We're determining whether this is linear, quadratic, or exponential. So, D1, what do you think that stands for?
Why is it so confusing?
First what?
First column.
Second difference.
First differences. Second differences.
Ratio.
First ratio, okay? So, 89 and 100, that went down how much?
Isn't it 89?
89.5 minus 100, what is that? Negative 10.5. All right, 78.9 minus 89.5, what is that?
Minus 89.
This one minus the one above it.
Negative 10.6.
68.4 minus 78.9. Negative 10.5. 57.8 minus 68.4. Negative 10.6. Wonder what these are going to be. This is these difference. That's what? It went down 1, not down 0.1. And then it went up 0.1. And then it went back down 0.1.
When we go with
Alright.
quadratic.
I would not go with quadratic, actually.
So you go
Same number is
with
different. Yeah, never mind.
Yeah, I'm going to go with linear.
Yeah.
I am going to do the other ones. 89.5 divided by 100 is 0.895. 78.9 divided by 89.5 is 0.8816. 68.4 divided by 78.9, 0.8669. And last but not least, 57.8 divided by 68.4 is 0.845. So I would definitely call this one what? Linear, okay? And then it says, then use the regression to find the function that models the data. So I would take my information here, go to my stat, edit. I'm just going to do it in my calculator here in my hand. We got 0, 1, 2, 3, and 4. Then we had for L2, we got 100, 89.5, 78.9, 68.4, and 57.8. And I hit stat again, go over to calc. This time I'm going to use which one? We already said it's what?
Linear.
Linear, so I'm going to use linreg, which is number 4. And that tells me that I should get y is negative 10.55x plus 100.02. Okay? Any questions?
Wait,
Yes,
so
which
you go
linreg did
stat,
you use?
The first 4. They're both the same. For some reason, on one of them, they put A in front of the X and put B behind it, and on the other one, they put B in front of the X and put A
So
behind
what
it.
happens
I don't know
after
why.
you plug them all into your table? Where'd you go?
Stat, every time. Stat, over to calc, figure out which type of function it was.
Isn't it linreg?
Linreg, number 4.
Which one? Oh, number
Okay, so you press count.
And then you chuck
It's stat first, and then go over to the right to calc. And then scroll down to linreg, number 4. Everybody get those for A and B? And from there, it's just plugging in.
Yeah.
Okay? All right. I think I gave us,
There
yes.
was no C because it started at 0, right?
I'm sorry?
There was no C because it started at 0.
There's no C on linear anyway. Linear equation, y equals mx plus b. Okay? All right, yeah. That was the slope was what, 10? Yeah, because it's a line. Yeah, slope is negative 10.55, and it's the y-intercept is 100.02. Okay? That is up there. All right, so here's the graphs. We're not going to do this real well. We are, but we're going to talk about it. It says the graph shows population models for 3 cities based on data over a 5-year period. If the population continues to increase the same ways, when will the population of city C exceed the populations of the other 2 cities? So what you're going to do, grab your calculators, go to y equals, okay? When you go to y equals, make sure at the very top, none of your plots are on. See, it says plot 1, plot 2, plot 3. Make sure none of them are highlighted, okay? If they are, click on it and unhighlight it, all right? So let the first one be 3.2x. Let the second y be 0.25x squared. And let the third y be 2 to the x minus 5 power. So city A is, what kind of graph is city A? It's linear. What kind of graph is city B? It's a quadratic, and city C is an exponential. Okay. Hit the little caret button here. Hold on. Let me get out and go. It's in your book.
Oh, I see.
All right.
Right above the divide.
So you're gonna hit y equals. Okay. Somebody read it to me. What was the first one? 3.2x is right there. Scroll down.
0.25x squared.
0.25x squared.
And then 2 to the x minus 5.
Here's the little exponent button right here. Okay. 2 to the x. And you just type in parentheses x minus 5. I don't even think you have to do that on yours. I think it automatically jumps up there to the exponent. Okay. Everybody good? And we hit graph. And there's our first one, there's our second one, and there's our third one. Okay? All right.
Why did nothing show up on mine?
Hit zoom 6 if you're not seeing anything.
My thing is wider.
Hit zoom 6. Okay, zoom 6 will always make it be the standard window on your calculator.
That's how you do
So how long has it been messed up for?
I don't know.
Because I haven't been able to see anything for a while.
Is yours still going? I don't know. I guess maybe you need batteries too. I don't know. That's. Hold on. I do know. I think somebody's been playing with the calculator. Y'all don't play with the calculators.
We definitely don't do that. I don't know how to even use it regularly.
They go down to the very bottom where you can't see and type in something, and that's what they do. They think they're funny. Is yours still going? You're good now? Okay. All right. Now, the question says, use this. Okay, it says if the population continues, when will the population of city C exceed the population of the other 2 cities? So, wouldn't it be nice if we could like see all 3 tables up against each other?
You can.
You can. You hit second and graph, and see how it says blue table up there? That's going to bring up my tables. Okay? So, notice the x's don't change because the x's are the same for all 3, but the y's are what's changing. Okay? So this is y1 is my first, that's my line. y2 is the quadratic, and then y3, which you can't see, or I can anyway, you might can. I just have to scroll over to see y3. Okay? So the question is asking, when is y3 going to overtake the other 2? You got me? So I need to keep scrolling down until y3 becomes bigger, right? So it looks like at year 10, let's see if it's bigger than the other one. Ah, it's the same, right? Okay? So after year 10, guess what? City C is going to have more people than everybody else. Okay? And that's all you do. You just use your table and your graph to see that.
So you can just
Okay?
put it
The
on.
whole thing's in your calculator. Ain't that great?
No work.
No work to show.
Amazing.
Easy peasy. All right? Let me go back. Desi, you need to get above the line. Right now, young lady.
I don't have that fond away. Did you not see my last grade?
All right. Number 3.
Graded it.
3 is just what we just got finished doing. So I think that was the last example. Yeah, they have some. Let's figure it out. We're going to figure out just real quick what type it is. Okay, just a few more examples. So this one's going up by what? 3 and 9,
I don't think it's 7.
15,
I looked at 3, then it's 10.
21, right? So is it linear? Nope. All right, let's try this one. That would be 6, 6, and 6. They're all the same, so it has to be a quadratic. Let's do another. All right, this one. How much did it go up by? 5, 5, 5, 5. So it's a linear. Okay. Thank you. All right. You have numbers 11 through 18 and 21 through 22 to do. If you are watching this at home,
Have a great day.
have a great day. Stay above the line, and we will see you next time.